Magandang araw po sa ating lahat na imbagal daw kanya to'y amin. Right now, we will be talking about the test probes of an analog multimeter. We are familiar that the red is the positive and that the black is the negative. But this is not always true. Like in the case of measuring the alternating current voltage. Because in alternating current, there is no polarity. Therefore, we can interchange the test probes but still get the same value. Unlike in measuring direct current voltage that there is a polarity. We have the positive and we have the negative. And the polarity should be followed. It should be positive to positive and negative to negative, therefore we have a value. If we do the opposite, the pointer of the multi-tester will go in the reverse direction. If we will be measuring the value of the resistance, the multimeter will still measure the resistance even though we interchange the test probes. But when testing diodes and transistors, we set the multimeter to ohms, then we should follow that the black is the positive and that the red is the negative. This is where many people get confused. Like for example, we will be testing this rectifier diode. The black part is the anode, that is the positive, and the silver-coated part is the anode, that is the negative. Again, when the multimeter is set to ohms, the black is the positive and that the red is the negative. So positive to anode and negative to cathode, and we have a continuity. This is the forward bias of the diode. When testing this diode on its reverse bias, we have negative to anode and positive to its cathode. And at reverse bias, there is no continuity. Let's test this LED. We know that the longer terminal is the positive, that is the anode, and the cathode is the shorter one. Therefore, positive to anode and negative to cathode. And we can see that the LED is emitting light. On its reverse bias, that is positive to cathode and negative to anode, there should be no light. Hopefully we learned something right now. Thank you for watching. Good day to every one of us.